So I think, using the whole idea of vibe coding is really interesting. I saw some study came out recently that, they had developers assess how much faster they were with it. And then they actually measured their speed according to some metric. And it showed that on average, people thought they were faster, but were actually a little bit slower. Yeah. And I think, to me, it's a skill issue. I think there's a smart way to use these tools and lots of dumb ways to do it, and it's not obvious which is which.
We're learning how to use them. I've noticed that I wrote this whole app in one day, right? Mm-hmm. But now we've been fixing it for like 3 months. So that's kind of the short of it.
Right. Like, you can accidentally create a lot of technical debt, and so that. But at the same time, it's sort of, it's the same thing with like hiring, say, junior coders. You can sort of like give them a high level goal, and they'll scramble to reach it, and probably not take the shortest path, and then and maybe it's fine at first. I think you can't, if you insist on having perfect architecture and everything from the beginning, you kind of end up slowing yourself down and never really push it out the door. It's like sometimes you have to.
It's very good at solving the blank page kind of syndrome, where you have a blank page and you don't know where to start. You just tell AI, I want to do this and this, and then you don't have a blank page anymore. You just have you have a structure.
Right, and some people like we'll get like a template, like create React app or something, and then throw the AI at that, where it has like certain design decisions are pre-made and.
But I feel like all of this stuff is going to get really good, and we are actually going to have a 10x experience. Right now we have a 10x experience for a while, and then it slows down and it turns out to be a 2x experience, because you have to fix I'm just in the middle of fixing old code that was not written well, because it was all AI. And, we got pretty far with just using basically no architecture, just do it however you want to do it. And then there was one feature that just puts it over the brink.
Right.
It's like in software development long enough. I know that we can't add another Band-Aid on top of this, because then we end up with a super buggy product that, has just many, many bugs, and we constantly fix bugs. So we have to go back and re-architect it and make it proper. And then, we lost some of that time now.
But I think that's, I think every successful startup has to throw away code. That's if you only create code and don't delete it, you're going to have you're going to end up like Microsoft, where you have 10 million lines for your operating system and nobody knows how it works. And now you have 30 million lines that's supposed to test the 10 million lines, but then somehow it still doesn't fix it. And so I love deleting code. I actually like it. I like it more. Wow. Somehow it feels like
it's a great gift to have, that you love deleting. I hate deleting code.
Oh, really?
Because something is already working. I don't want to do it again. But there's a whole philosophy where people say, okay, you write the app and you make it work, and then you throw away all the code and write it again. And that's actually the best way to do it, because you end up with a much better architecture, because your understanding of the whole problem space is much better.
Sure, it's sort of like forest fires actually promote biodiversity. So but also they do take time. So you have to balance all these things. There's no I
get attached to it, and I'm like, hey, come on, we can still use this, and then
it's my baby,
you have to be able to throw out the baby and be like, no, let's have a new baby.
It's true, and sometimes you throw out the baby with the bathwater, and it's like, okay, actually, we could have kept some of that, And I always think there's no one system that always works. It's always like a judgment call. You got to show up and evaluate the current situation and be present and be like, okay, what does this situation actually call for? And there's no one formula that will just kind of rule everything.
Going back into history as software engineers, we know that 95% of the time, it's the right thing to do to throw away everything and just start over. Also, when you find a new code base and you're supposed to reuse it, most of the time, unless it's a very good 5% percentile, highest level code, you probably can't reuse it. You probably can't build on top of it. It has to be super good, with unit tests everywhere, really well designed. And it's hard. It's usually you don't find that.
It's a high bar.
Yeah, it's a very high bar.
Yeah,
very high.
But it's been interesting, working on Substrate, working in the Polkadot ecosystem, and Gavin's some insane genius, and you can kind of see the further away you get from him in the ecosystem, the worse the code is, and so the chain is very abstraction heavy, but actually quite well made.
Yep.
And but there's definitely a significant learning curve to
There's a massive learning curve in Polkadot. It's interesting because it's maybe one of the very few times I've seen a very complex code base that is very good, actually.
Yeah, like they actually needed those abstractions, or most of them.
It does like things that are magical, So it's like, okay.
Like when we finally found the right place to insert the post-quantum signatures, it was like, oh, this is not a deep surgery. Like they didn't really, it was hard to find that spot, but once we found it, it was like, oh, you can just, cut this out and stick your thing in. Yeah.
And AI was failing very badly at the code base because it's not well documented, and it's been changing constantly. So there's a lot of old documentation out there, old versions. So AI was pretty useless in the beginning.
Yeah, one of the tricks I found was that if you can vendor, you download the code base and then you vendor everything. So you bring all your dependencies into the folder, and then you can tell Claude or whoever it is to go look at what the code actually says. Don't go read about it online, some outdated documentation or some previous version. Like go read what the actual it's like command click, and it definitely improved the sort of the hallucination rate quite a bit. But it's like, it's a word cell, it really kind of, it's good at talking. Oh, do you know this term?
Word cell? No.
So there's like this, I don't know, this sort of categorization of people. I think it comes from Twitter. I don't know, but like word cell is like people with like higher verbal IQ, and then shape rotator is people with like more spatial IQ.
Okay.
So
I know people like that.
Right.
It's a very good description.
It actually is. It's a pretty cool concept. And so it's like, okay, is it like a Rubik's
Shape
Cube
rotator.
or somebody who reads a lot, So the AIs are mostly word cells, they're like, they can talk in a very impressive way, they can write an email great for you, and computer science is interesting because it sits at this intersection of both verbal and spatial intelligence. Like you can actually approach it from either side. And when I was taking higher math courses, it was interesting because like in the higher math courses, about half the students were women, but they tended to gravitate towards like the things like combinatorics or algebra that were more about like symbol manipulation, versus like topology and geometry were mostly men. And so it was this kind of interesting,
spatial versus verbal skill set.
Yeah.
Yeah.
Versus in the computer science courses, it seemed like it was like almost all men. And even though to me it felt like it was actually more of a kind of a word cell thing.
It was all guys in mine too.
Yeah.
Like one girl in the whole course.
So I don't know. I mean, it's the things are, everything's complicated, but
I think there's like a whole future that I see of people generating like tons of code by orchestrating AIs. It seems like that's, I talked to a friend of mine yesterday. He was super excited. He was up every day until 5 a.m, 16-hour days, just having like tons of instances of Claude code running all at the same time and manipulating all his repositories at the same time and just telling them what to do and then figuring out what they did and like, just like, and the guy at the orchestra that directs like the music, right? And I feel like that is very interesting.
It is.
To me. I want to be like that too, actually. Like the AI needs to be better and faster. Right now it's kind of too slow and not good enough. But once it's a little bit better, like if it can match my level of coding, that'd be awesome. It's just like
right now you've got this like force multiplier.
Directing all these AIs and writing tons of code and making products in no time. So it's super exciting actually.
Yeah, it's not. I think the tool looks simpler to make than it really is. Or to use than it really is. In the sense that like I think a lot of people approached vibe coding, knowing nothing about computer science and like it'll make you a basic React app and you can like make a simple web page but there's like beyond a certain level of complexity it kind of falls apart and you probably need some expertise, it's like this idea that every abstraction leaks, like you can build on top of an abstraction for a while, but at some point it's going to leak and then you're going to have to go look underneath the abstraction. And if you're not willing or prepared to do that, which could look like, okay, now I need to understand how a queue works, or now I need to like open the library I'm using and look inside and see how it's written, or there's all, and to me, that's like, there's this sort of like subset of the population that is quite interested in technology, but doesn't want to sort of get their hands too dirty, in the sense of like, they don't want to wrestle with the compiler for hours. And that's sort of like, I think maybe the only way you can really understand what's going on beneath that abstraction layer. But you don't have to be that person. You can also team up with that person, or you can, you can ask, and more, if you know the kinds of questions to ask, or the kinds of things to say to the AI, I think that helps a lot. So just having a basic vocabulary of the underlying abstractions makes it a lot easier to say like, hey, I think this might be what's going on. Can you check? But there's also just a lot of tricks you can just like ask the AI to evaluate itself and be like, hey, did you reuse existing code, or did you write, like, which piece of code is most similar to what you just wrote? He's like, oh, wow, you're right. That's amazing. Like, I didn't need any of that code. Wow, I could just reuse this thing. Okay, wow, great job. Like, oh, is there anything you could simplify there? Can you just delete some of that code and keep the same functionality? Like I asked it to write a README, and it was like pages and pages. I was like, I'm not gonna read it. Nobody else is gonna read it. It's like, can you make it 1/10 the size? It was like, you're right. And it did, and it was actually a good README after it fucking, you have to tell it to like, shut the fuck up, stop making too much.
Yeah, it operates in a different way. It's very happy to code new code that's similar to existing code. It doesn't really care that, you could simplify that. But it might be that this AI coding is just a new level of abstraction, like the same way that we don't use zeros and ones, and the same way we don't use assembler code. And assembler code, on top of that is C code, on top of that is some other like Java or whatever, or JavaScript, and then it goes the levels up. It could be AI, it's just another level of abstraction on top of everything.
Totally, and there are people who still look at machine code, but it's a lot smaller proportion than it used to be. It used to be like, you didn't program unless you were doing the punch things.
I wonder if it's the same number of people though, because the number of people has expanded in the meantime, right?
It's a good point. So there might be some like conservation law in there somewhere.
Constant value of 10,000 people coding machine code.
Well, I think it's more, in my experience, the people who are into the machine code thing are either like doing like, micro optimizations for like supercomputers, or I think more often they're security researchers, and it's like
embedded systems, where they have this very small memories. And
that's another category. Yeah. That's right.
The people I met that were doing that. They were just programming little small devices.
I saw this guy. I think it's important in whatever discipline you take up to have some kind of hero or some kind of like somebody to look up to. And I think the person that I have been most impressed with in the world of computer science, I mean, obviously, there's like people like Alan Turing or whatever, but, I didn't actually meet him or see him on a YouTube video. But this guy, Chris Domas, I don't know if that's how you say his name, but he has this DEF CON talk of psychological warfare and reverse engineering. And it's just like, it's such a like, it's so clearly thinking on like another level of like, he's like, okay, yeah, you wrote some code, it's closed source, somebody gets the binary, they're trying to reverse engineer it because like maybe it's malicious or something. And I think this guy probably works for the government, but like, it's fun to watch. And so he's like, well, okay, so some people typically use this reverse engineering tool called IDA Pro, where it will take all the sort of machine instructions and arrange them in a dependency graph, and it has a way of laying this out. And he said, well, that's interesting. Well, there's some machine instructions you can put in that will change how this layout goes without changing the functionality of the program. So you can kind of like, you can start to make shapes in this graph. And so he figured out how to make it into a bitmap, where it would just like, now you have like your program, no matter what the program does, when it compiles, IDA Pro will render it as a grid of gray. And he figured out, okay, I can actually make one of these darker or one of these less dark.
So it's to obscure what it's actually doing?
Well, yes, one, to make it hard to figure out what the fuck it's doing. But two, to start, he was thinking like, how do I fuck with the person who's, how do I intimidate the person who's trying to reverse engineer my code, right? And so, oh my goodness. Yeah, it's an insane even thought to have. Like, But anyway, so he figured out how to make it where like some of these pixels in the bitmap are darker, some of them are lighter, so now he can render an image. So he made this fucking compiler that will take your program, and then it will also in the program it will go look in the person who's running it. It'll look in their home directory for images. So it might be like an image of their family or something, or like a picture of their dog. And then it will rewrite itself so that when they look at it through IDA Pro, they see a picture of their family.
God, that's a mastery.
I would stop. If I was trying to reverse engineer that, I'd be like, oh, wow, this program is rewriting itself to fuck with me. Like, of course, this is actually a very impractical technique because all these extra instructions do slow it down and like, you know. But he made
even introduce errors.
Right, like you have to be guaranteed that these are actually no ops, and sometimes they are, sometimes they are. But he also made this at the beginning of that project was he made so somebody wrote a paper that MOV in x86 is because of its peculiarities of when it moves. It's called an unconditional move, but there actually is some conditionality in there, and so it basically that single x86 instruction is Turing complete, meaning you could, in theory, write any program entirely with that instruction. So this guy rewrote GCC to only use that instruction. So when you compile your C program, you just get all moves. But then somebody compiled Doom with it, and it's like it runs at like 1 frame every few minutes. It's like completely impractical.
Okay,
but it's an interesting thought experiment.
It's pretty interesting. It's pretty cool. Yeah. I thought it was really interesting when these guys were reverse engineering the hidden CPU that's inside of the Intel CPUs and how to address that CPU. And he was just running all these, testing programs that were just fuzzing it with all kinds of possible combinations of commands until he found the commands that would actually address the inside secret hidden CPU.
Yeah, it's amazing. It's like
that was incredible,
right? It's like, hey, when I put this, it's kind of like picking a lock. It's like when I send this instruction, for some reason the CPU takes a little bit longer than it should.
Yeah.
So somebody else is listening in there, And I mean, it's kind of it reminds me of the quantum key distribution. I was reading about that recently. So they can use the laws of physics to detect if someone is eavesdropping on a connection, and which is a kind of a whole different level of security than you could ever get before.
Because you can get that from quantum transmission because the observer changes the observed.
Exactly. Yeah. So you have a certain expected probability distribution, and then if somebody's you have entangled qubits and you're like sending them across
right.
And then if somebody's if Eve is eavesdropping on the line, she'll change that probability distribution, which is sort of this whole Bell's inequality theorem where you get a slight probability shift by observing one of the entangled qubits and so that's quite cool. To me that's like a kind of miraculous. That's not just like this computer is faster. That's like this computer is doing something different at a fundamental level. But of course, you pay the price because now you have to deal with this super unstable, microscopic, fragile behavior. And
it's interesting. I haven't really researched into that much, but I was thinking if you have quantum spins, they're basically teleporting, right? So you should get lag-free connections with this and things like that.
Yeah, it turns out using the
over any distance because they changed their state here, they changed the state there.
Right. So it is kind of it gets you this sort of on the one hand it's very fast, but then keeping those two qubits entangled as you separate them.
That's difficult.
That's the difficult part. Is you sort of you have to make sure that nothing interferes with them as they So you kind of end up having to pay for it in a different way.
All right.
But no, to me it's the sort of I saw this paper recently where they interviewed a bunch of different physicists about their interpretation of quantum mechanics, and there was no consensus. It was all over the place. The Copenhagen interpretation was the sort of it got 36%. But it was kind of that's also kind of the default of how it's taught. So it's almost kind of it's almost like a no vote, but not exactly. And then there's the many worlds interpretation, and then other people are, there's all these different interpretations of quantum mechanics. So there's no consensus on what the fuck this actually means, and it's just like, okay, the math works out, and the computing model is completely agnostic to which of these interpretations you have. So it's sort of like
quantum computing.
Yeah, exactly.
Okay.
So it's sort of like, it's a little bit of this like, physicist masturbation thing where there's like, oh, I'm going to do a thought experiment and charge the government $1 million. Like, okay, does it really matter if it's many worlds or the observer collapsing the waveform? Like,
the most interesting thing that I think about, that I find about quantum physics is that it kind of merges with spirituality, where it shows that, actually the world springs from within and not from without. So all the science looks outside to find the truth. But if you go from like spiritual principles, the whole world comes from within. So you are always the observer of what you're observing and changing everything that you're observing all the time. And we don't really know, like there's a lot of mystery behind how that's supposed to even work. But quantum physics goes in that direction. It says, oh yeah, when you are looking at something, you're changing what you're looking at, right?
Right,
it's changing.
And I think the
it's
sort of
hard physics, so that's why it's cool. It's not like woo woo, Ubudi and cacao ceremony. No, it's like this is hard physics. This is a physicists saying that.
Right, and because a lot of, I think, like science at some point realized that like humans are biased, and they kind of like, you can kind of accidentally influence an experiment by with your biases or your preconceived notions, right? And so then the whole idea of science is like, okay, you're gonna test your own hypotheses, you're gonna try to prove it wrong to kind of like cancel out that bias, which is a very valuable thing, insight that led to a lot of progress, but also like so like in quantum computing, there's this idea of like in what basis are you measuring the qubit? Are you measuring it like that basis, or is it like that? It's sort of you're kind of like asking it, what are you, a 0 or 1, or are you a plus or minus? And it'll always give you an answer in the kind of frame that you give it. If you ask if it's a 0 or 1, it'll always answer.
Yeah,
I'm a 0, I'm a 1. It won't tell you anything different because you've only asked it. Are you like polarized like this or polarized like that? But you can ask it you can bring a different context to the question, and it'll also answer that. And so to me, that if you're going to map that onto psychology, you would say, okay, the sort of subconscious context or framing of your perception is deeply influencing the way you experience the reality. It's like,
it's basically the placebo effect, which is also scientifically proven.
That's right.
Like beyond a doubt, in statistics and everything. Yeah, there's like 30% placebo. If you have some pill you give to some people that actually just received a sugar pill, 30% of them will experience a positive effect, what they thought would happen, just because of the placebo effect. Same with the nocebo effect as well.
What's the difference there?
Nocebo is when you believe that something terrible will happen. It makes it much more likely that something terrible will happen.
Oh, interesting. Well, I saw this paper. I don't know. I didn't look deeply.
Or you think that something won't work. The nocebo effect is like, yeah, it won't work because you believe very strongly that won't work.
Right, and there's all these different layers at which you can be affecting that, right?
Yeah.
It could be just like you don't try, or you don't try as hard, or you subconsciously sabotage someone else who's trying. There's all these ways in which it percolates through the layers.
Yeah, but when it comes to your own body, you have a huge effect with your mind on your body. So
Absolutely.
The nocebo effect will totally make some things not work for you and other things work for you.
Well, I saw this interesting paper, and I didn't look deeply into the details. I don't know how rigorous their method was, but they found that having frequent nightmares was a great predictor of early death. And
whoa,
isn't that just
pretty dark?
It's pretty spooky, right? It's like whoa, is it? But I think it maps into this sort of thing that like when you have this sort of the story you're telling about yourself, whether that's like the creation story of the world and like what your purpose in life is, or the story about your family and where you came from, all this stuff affects your health and your strength, your capabilities. And my experience tutoring is that like a huge amount of variance in people's performance in school is based on basically psychological or emotional issues, more about like basically self-limiting ideas about like what you can and can't do. is probably holding you back more than anything else in your life. And, it's not that you need to be delusional and like sort of, kind of lie to yourself and ignore your own mistakes. And that's actually the opposite. But, instead of internalizing the mistake and being like, oh, this means I'll never be able to write with my left hand because I didn't do it on the first try,
Yeah, there's a middle way between delusional and, negative delusional, where you think you can't do anything and when you can do anything. So there's like a middle path of things that you are supposed to do, basically, in this life. So,
yeah, when you're talking about earlier, this like, your placebo effect, it reminds me of this concept in yoga of samskaras, of like these sort of like deep unconscious impressions we get from the things that happen to us, and they can be like positive or negative. It could be extreme pain or extreme pleasure we felt, but it creates this kind of like neurons that fire together, wire together, right? So you have some intense experience, and then your brain kind of glues that experience into the thing. You're like, okay, if I ever see A, we're also going to do B because that's how it works, and so that gets kind of like, but that ends up kind of influencing your perception of reality and your behavior, and
it becomes a pattern, like a computer program, right? And
absolutely.
then you're not really aware that pattern exists until you do become aware of it, and then that's the time when you can let it go and say, oh, there's a pattern appearing in my brain, but I don't have to act on it because you're now aware that pattern is happening. But before that, when you're unconscious of the pattern, you will just act like a robot. You will just see the thing and do whatever the action is that you think must be done when you see that thing, right?
Right, yeah, okay, the conditioned response,
yeah,
essentially.
The conditioned response, right. So you decondition yourself. So in yoga, I think also the idea is always to get rid of your sanskaras, right? Isn't it? I mean, I haven't done that much yoga, but...
I think that's a good summary of it.
It just makes a lot of sense. It's just a life overview, like what are you supposed to do with your life? Yeah, you probably need to get rid of your sanskaras to advance yourself as an intelligence.
Yeah, it gives you more freedom to not be a robot and to not just have a conditioned response. It's like there's some saying in Buddhism, I forget how it goes. It's like just a little bit of space between. How does it go? A little bit of space between stimulus and response is all you need to make paradise. And this sort of like, because also when you're unconscious of the samskara or these patterns, you kind of identify with them. Yeah. This is who I am. This is my personality. I samalama ding dong. And
I have a religion, a culture, a nation, and that's what I'm going to do.
And we do this hand signal in my cult, and we
wear this hat.
That's right.
On this day.
And these are our colors. And if you have a different color, you're in a different cult. And right. And it's just like once you kind of like, I became fascinated with cults when I was in college because for various reasons I kind of grew up in like kind of a cult and then got out of it, and then I was like, oh man, there's kind of cults everywhere, and so I was like, go hang out with like the Scientology people. Yeah, I'm calling your cult a cult. That's right, Scientology people. and like I pretended to be interested in what they were doing and like took their personality test and their IQ test and everything, and and of course it came out that I'm really bad at math, but don't worry, Scientology can help me with my low IQ. And
wow,
and don't
that's total gaslighting.
L. Ron Hubbard had a 200 IQ, but yours is like a little below 100. So,
that's a typical cult thing.
I was like, wow, you're really trying to like humiliate me, and like and also I've taken other IQ tests before, and like yours was by far the easiest. Like they just took the like top half of the difficult questions out,
it's a classic red flag for a cult,
Yeah, but these things are kind of everywhere, brands are kind of cults, and
religions are the original ones. Then science is also a religion now, like scienting, which is not real science, which is ours, because I come from a very scientific background. My whole family is all scientists and PhDs, so I'm always like really grossed out by this scienting ideas, in the media, like, oh, these experts say something, but you don't
trust the experts.
Who's paying these experts, and who benefits from this?
Absolutely,
it's the same thing. Like, who benefits? Oh yeah, who did it?
Yeah, and this sort of like the error is they treat science as a noun, like a body of knowledge that needs to be sort of absorbed and then regurgitated, versus
knowledge.
the act of updating your model with, you know, when you have new information and like looking for a more parsimonious explanation of the data, and you're constantly getting new data. So, and you know, because if you freeze it, now you're in dogma world. You've just like, you know, and now you have to defend it.
So AI is also this religion, because AI is frozen. It's built on a body of knowledge that it regurgitates, or whatever, however this is pronounced.
Yeah.
But it just keeps repeating whatever is in this body of knowledge that was in its training model.
Yeah, and so it can sort of elaborate on things and kind of read between the lines and stuff like that. You know, but it does kind of like your training data. This is what I think is missing from AI research is people, have you heard this term context rot? So the idea is that like if you get something bad in your context in a conversation with the quality of the conversation will just decay and decay and decay, and I
didn't know that. Okay,
and it's just better to just start a new thread.
Yeah, I've done that.
Right,
I've seen it. I didn't know that it's called context rot.
Yeah, and so I think humans also have context rot. That there's like
for sure
some stupid stuff that gets into your context, and then you just kind of like become dumber over time.
Especially in groups, the group starts to discuss some really ridiculous stuff, or goes into like a very stupid lever, and then everyone just isn't a lever in that group.
And so, but I think, you know, our mammalian brains have a built-in mechanism for that, and I think that's memory consolidation during dreaming. And so the idea is like, you know, you kind of like, because dreams are kind of like lossy compression of your experience. You know, they kind of like, it folds different characters on top of each other. There might be one person in a dream that kind of is like a mixture of like your lover and your family member and your, you know, and your boss or something, you know, like there's all these kind of, but in this way they kind of map onto each other and have something in common. So we're just gonna have one symbol for that. And you get this sort of like folding, and you lose a lot of detail, but maybe the detail is mostly irrelevant. So you kind of keep the more important things. And so I think that's how humans deal with context rot, is that you forget a lot of things that happened and just kind of summarize them. And kind of try to keep what's important.
We definitely forget a lot of what's happened.
For sure.
Like yesterday, I couldn't tell you what I did. I know I went to one place, but it was a 24 hours period. So.
Right.
That's just one thing that happened.
And it would take you about 24 hours to recount
tell you everything.
Exactly. And so, you know, so what's the point of a map if it's as big as the territory, right? Yeah.
Maybe that's why we forget everything. Yeah.
But I think there's also this idea of like indexing your memories, where you sort of like, you know, is this like, you can decide when something happens, you can decide to remember it, you know, and you can sort of intentionally sort of map it. And people use like memory palace techniques, or like, you know, but this sort of like skill with like intentionally putting things in long-term memory. Like if you want to memorize a poem or a piece of music or you know, something for a test or something. And to me, it maps very elegantly onto the notion of indexing a database. It's sort of like, you might have all the information in there, but how quickly can you find it? Do you have to search it from beginning to end? And like, okay, what happened at 1 p.m.? Okay, it wasn't there. What about 2 p.m.? What about 3 p.m.? Right? It certainly doesn't help with conversation. You know, you're like, hold on a second, let me sit and think for 5 minutes before I, you know, before I answer your question. You know.
Yeah, I don't know how that system works, but I feel like it's taking care of itself. So I'm not trying to manage it. It's like whatever I need to remember, I'll remember. And if I don't remember it, I probably didn't need to, or was not meant to remember that at that moment.
And I think that's sort of the principle of neurons that fire together wire together. It's sort of like if you access it many times, then you'll strengthen that connection.
Yes,
and
absolutely.
And so that's kind of a natural heuristic.
There's like millions and millions and trillions of body processes that happen all the time, right? That we don't manage and we don't control. We're just living this moment to moment scene. We have the scene now. We're in a scene. And then we go out of this room. It's a different scene. And you know, whatever happened before, it doesn't really matter that much. So we are kind of like moving from scene to scene in the life. And everything is kind of taken care of. The body sleeps, the body eats, and then like we do all the basic functions, right? Reproduction.
It's sort of like an abstraction layer that you can.
It's all taken care of. We don't need to worry about these things.
Except for sometimes it breaks and then you have to fix it, right? The abstraction leaks and then you're like, oh shit, wait, why is my heart not working correctly? Like what happened in there? Oh shit.
Yeah, that's true. That's true. But mostly I feel like everything's taken care of. Like if I start thinking about how many things are happening in a body all the time, there's no way I could manage any of this.
No.
I don't have the time. You know? Even if I spent all my time on it, I wouldn't be able to manage.
Right. Like, okay, I need to go through 1 trillion cellular processes.
This blood needs to be flowing, that heart needs to be beating, that needs to be firing, that needs to go on. I mean, there's like millions of things.
It's true. It's true, but I also think that's one of the benefits of meditation is you can kind of increase the amount of things that you can notice in your body. You talk about listening to your body earlier, like I think a lot of people are quite disconnected from their bodies and like their bodies will scream at them and they still don't hear it, and so how do you increase your perception of what's going on in your body? And I think part of it is just fucking sit down, stop talking and watch.
You can watch your body and you can learn a lot about your body, which is interesting.
Yeah, like oh wow.
Or you can watch the awareness. And you can learn a lot as well.
Which is sort of the same thing. It's just another part of your body. There's like your brain's doing all this shit and you're like...
It's outside of your body, actually. So you kind of go outside and it's like, oh, what's aware of all of this? Including the body, including the thoughts, including the mind, including everything. What's the awareness that's aware of all of this? So you try to like go there and watch that. And then you get outside of the mind space, because everything that in this world is like inside of our mind space, mostly like thought space. Everything we see, we think about, we have thoughts. But there's an entire huge part of our being that's outside of the thought space as well. And we can't talk about it because every talking is just thoughts.
That's right. Yeah.
We can just say it exists, but we can't really have a discussion about it.
Well, but that does go back to the Samskara thing of like, how do you sort of like pop out of the programming, is this sort of, it's a little bit of like it's like a meta thing.
It's a technique, actually. This is a technique to pop out of the programming. That's very efficient. Actually,
I remember my Qigong teacher would have had a visual exercise he called exiting the program. And he would have you first look into the distance, take a breath, and then find something slightly closer, take a breath, something slightly closer, take a breath until you're like focusing on something in the room, take a breath, and then until you're like focusing on your nose or like the stuff swimming on your eyes, take a breath. And is this sort of like zooming out, like exiting each program, And I thought it was quite elegant and beautiful, and
I think all these techniques, because that's also a technique to move your awareness. All the techniques that intentionally move your awareness are actually exiting the program, because you realize there's an awareness that's aware, and I can move it around. I can like move my awareness over there and pretend to see everything from over there, like the non-locational awareness.
Right, and so it disrupts the identification with the thought.
Yeah. Like, it creates that break.
Yeah, just
that
a little bit
space between the thoughts and
a little bit of lube. Just slip out.
The empty space creates empty space. That's right.
There's no liquid in there. It's empty.
Yes.